Testing for cations. Preliminary tests with the salt may have given some indication about the cations present in the sample. However, cations are definitively detected and confirmed through a systematic analysis involving wet tests. Qualitative analysis classifies the cations into 6 groups. So please pause the video and look through the different groups on the left side here, right? Group 0, 1, 2, etc. And you can see the cations that are in each group. Preparing a clear and transparent salt solution is critical. The below fluids are commonly used in this order: distilled water, cold or hot; dilute hydrochloric acid, cold or hot; and concentrated hydrochloric acid, cold or hot. If gas evolution occurs during the preparation, let the reaction cease. Gases can be expelled completely by warming the solution. If the solution is prepared in hydrochloric acid, group 1 cations are absent and proceed to group 2. If the salt is soluble in hot water and on cooling white precipitate appears, lead chloride is confirmed. If the solution is made with concentrated acid, dilute with water before doing individual tests. The table lists a suitable solvent for a variety of salts. We have the room temperature distilled water solvent, and that will dissolve, or the salts are soluble in them, ammonium, sodium, and potassium salts, all nitrites, nitrates, and acetates, most sulfates except those of lead, barium, calcium, and strontium, all chlorides except that of lead. Hot distilled water, you have lead chloride and lead nitrate, and then dilute hydrochloric acid. All carbonates are insoluble in water, and then they give you a bunch of examples here, but not lead. Separating cations into 6 groups can be done by using reagents known as group reagents. These reagents work based on the differences in the chemical properties of the cations. So please pause the video here, and this shows you the cations, and this shows the form in which they're precipitated. So take some time and check out all these reagents and cations. And when you're ready, unpause the video and move on, please. The unknown substance may be a simple salt or a mixture of salts. This procedure eliminates cations in each step based on the group reagent. So step 1, which is referring to group 0 here, eliminating any ammonium or lead ions present, test salts in cold and hot water. Right, so here's water, the reagent. Then 2, prepare a salt solution, that's going down here, in dilute hydrochloric acid to identify any lead ions. And finally, step 3 on this page goes to group 2. If no precipitate formed in step 2, through a part of the above solution pass hydrogen sulfide. If group 2 precipitate is present, filter off and use the filtrate. If no precipitate is formed in step 3, use the other portion of the solution and add a pinch of solid ammonium chloride, then boil. So you're over here in the group 3 area. Cool the solution and add excess ammonium hydroxide solution. Formation of a precipitate indicates a group 3 cation is present. Step 5. If no precipitate is formed in step 4, and again step 5 here is group 4, use one part of the solution and pass hydrogen sulfide gas through the solution. If a group 4 cation is present, a precipitate will form. Step 6. Use the solution from step 3, boil off the hydrogen sulfide gas and cool. Add ammonium hydroxide solution and ammonium carbonate solution. Filtrate from any group 2 precipitate formed, or the original dilute hydrochloric acid solution can be used. Group 5 cations will be precipitated as carbonates if present. 7. If no group 5 cations were present, boil and concentrate the solution from step 6. Add ammonium hydroxide and ammonium phosphate solution. Scratch the sides of the test tube with a glass rod. Magnesium phosphate will precipitate if present. Reactions of ammonium. Confirm the presence of each specific cation through tests. Experiment. Add a little of the sodium carbonate solution to a small amount of the salt. Observation: no precipitate. That means that ammonium carbonate was formed, which is soluble. 2. Add a little sodium hydroxide solution to an aqueous salt solution. Observation: a colorless gas with the smell of ammonia. Inference: ammonium salt decomposes to ammonia. 3. Place a glass rod dipped in concentrated hydrochloric acid solution above the gas in the test tube from step 2. Observation: dense white fumes. Inference: formation of ammonium chloride. Caution: always waft when determining the odor of a gas. 4. Add Nessler's reagent to a portion of a salt solution. Observation: a brown precipitate. Inference: mercuric amino iodide complex is formed. Reactions of lead. Experiment: add dilute hydrochloric acid solution to a portion of the salt solution. Observation: a white precipitate is formed. Inference: lead chloride is precipitated. 2. Add potassium iodide to a portion of the salt solution. Observation: yellow precipitate is formed. Lead iodide is precipitated. 3. Decant the solvent from step 2. Add 2 to 3 milliliters of water to the precipitate. Boil, allow to cool. Observation: golden yellow spangles on cooling. Inference: lead iodide is precipitated on cooling. 4. Add acetic acid and potassium chromate solutions to a portion of the salt solution. Observation: yellow precipitate. Inference: lead chromate is precipitated. Reactions of copper. Add dilute hydrochloric acid solution to a portion of the salt solution. Pass hydrogen sulfide gas through the solution. Observation: a black precipitate is formed. Inference: copper sulfide is precipitated. 2. Add ammonium hydroxide to the salt solution drop by drop. Observation: a pale blue precipitate is formed first, soluble in excess ammonium hydroxide and changing to a deep blue solution. Inference: copper hydroxide precipitate formed is soluble in excess ammonium hydroxide. 3. Add acetic acid and potassium ferrocyanide solutions to a portion of the salt solution. Observation: a chocolate brown precipitate is formed. Inference: copper ferrocyanide is precipitated. Reactions of zinc. Experiment 1. Add ammonium chloride and excess ammonium hydroxide solutions to the salt solution. Then pass hydrogen sulfide gas through it. Observation: a white precipitate is formed. Inference: zinc sulfide is precipitated in basic medium. 2. Add sodium hydroxide solution drop by drop to the salt solution until sodium hydroxide is in excess. Observation: a white precipitate formed first, soluble in excess sodium hydroxide. Inference: zinc hydroxide precipitate formed is soluble in excess sodium hydroxide. 3. Add 1 to 2 drops of concentrated nitric acid and a few drops of cobalt nitrate to the salt solution. Boil. Dip a filter paper into the solution. Burn it to ashes carefully. Observation: a green ash is obtained. Inference: formation of a double oxide of cobalt and zinc. Reactions of iron. If group 1 and 2 are absent, proceed with the original salt solution. If group 2 is present, boil off the hydrogen sulfide from the filtrate from group 2. Add 4 to 5 drops of concentrated nitric acid. Boil the solution for a few minutes. Add 2 grams of solid ammonium chloride and boil again. Finally, cool the solution under tap water and add an excess of ammonium hydroxide solution and shake well. Reddish-brown precipitate indicates the presence of iron. 1. Dissolve the red precipitate in dilute hydrochloric acid. To 1 part of the solution, add potassium ferrocyanide solution. A Prussian blue color confirms iron. 2. To the second part of the above solution, add potassium thiocyanate solution. A blood red coloration confirms iron.